Lightweight, portable, innovative. TESCO's 6330 meter site analyzer is the most versatile and complete tool for testing the entire functionality of transformer-rated metering installations. Contact us today for a free demo.
Hello, everyone. Rob Reese here, Midwest Regional Sales Manager with TESCO. Today we're going to do a continuance on last week's presentation that Tom did. We're going to be talking more about CT testing, but we're going to do things a little different today. Tom focused on if you recall, the theory, a lot of the theory behind CT testing, and he also focused on testing in a lab, which has a more controlled and stable environment. We're now going to take this testing outside and focus on the field application. And as you all can understand, testing in the field adds a number of different variables, which create some nuances that you just need to consider when testing in this application. So we're going to go through all that in the next few minutes here. If anybody has any questions as we go along, feel free to use the chat function or just shout out, and we'll also have a question and answer session at the end of the presentation. So in the next little while, we're just, I want to do a quick review for any of those that were not on the call last week, talking about just an overview of the application and functionality of CTs, and then we're going to get into the in full and then detailed depth, the ratio testing, burdens testing, and admittance testing in regards to the field. We'll also go over De-mag functions and interpreting the results that you get with your equipment at the site. So just a quick review. I'll go through this quick. As we all know, there are a number of different meter forms out there that ultimately, and they each have their different applications for different services. Ultimately, you can divide these into two main categories, self-contained and transformer rated. Self-contained typically is for low current or residential applications. In self-contained application, all the current flows through the meter. But we're going to be focused on transformer rated metering, where you have a relatively high current, as in a commercial industrial application, where the load does not flow, all the load does not flow through the meter. And in these applications and installations, we utilize a CT. And now I know Tom got into the functionality of a CT in depth last week, but just as an overview and a summary and a quick review, a CT will ratio down a high current to a small current, typically under 20 amps, that a commercial industrial meter such as a 9S can safely measure in those applications. And throughout this presentation, I'm going to be using this example. It's a typical 9S meter installation where you have 3 current coils in the meter. And so you would employ 3 CTs to ratio down the relatively high currents, the 400 amps there, down to relatively low current, the 5 amps on the secondary, as shown in this diagram. First and foremost, just like with meter testing, all the information you need to execute a CT burden, ratio, and admittance test is located on the faceplate of the CT. Like with a meter test, when you go to execute a meter test on the faceplate of the meter, you have the case of H, the test voltage, the test current, everything you would need to execute the testing. Likewise with a CT, all the necessary information is on the faceplate. This information includes the ratio, typically something to 5 amps, and Tom explained last week that the 5 amps comes from the earliest of meters in the market. So a quick example, a CT with a 400:5 ratio will produce a 5 amp secondary when 400 amps are applied to the primary. The next specification I want to talk about is the thermal factor. The thermal rating you don't really test in the field. You would the testing would actually damage the CT possibly, but a thermal rating factor is if you have a 400:5 CT, for instance, and a rating factor of 4, that tells you do not apply more than 1600 amps to the primary of the CT or you're going to let out the magic smoke. It's the point at which the coil expands and because it is completely potted, there's nowhere for it to go and you will have a thermal breakdown and damage of the CT. You really do not test for thermal rating factor in the field. And then the last specification to review here is the burden rating. To explain the burden rating, CT manufacturers, they all do a good job. The burden test provides and puts a operating range on the CT that if you go beyond the operating range, they can no longer guarantee the accuracy of that CT. CT manufacturers make CTs, which is basically a widget. Every manufacturer makes units, and these units are bound by the laws of physics and manufacturing and component properties. And so the CT manufacturers can only guarantee the accuracy of the ratio as long as you do not exceed the burden on the secondary loop of that CT, which we will get into more later on. So as far as ratio testing in the field, you typically would utilize the test switch in the installation. If you do not have test switches in your installations, you're not dead in the water. There are manufacturers that make test adapters that allow you to pull the meter, apply the test adapter, which give you the necessary connections to utilize the duckbill style probe to take your current measurements. And basically ratio testing in the field, you would test you would make a current measurement on the primary of the CT, and then a current measurement on the secondary of the CT and calculate the ratio. Now, yes, you could easily do the ratio testing with a simple flute style meter with a clamp on current clamp. However, the caveat there is the time between testing the primary and secondary of the service. Say, for instance, you have pull top CTs, and there's a few minutes between taking the primary measurement and the secondary measurement if there's a fluctuating load, a fluctuating current customer load, that can throw your numbers way off. So instruments utilizing CT testing equipment such as TESCO's 1047, 1044, or 6330, those instruments take the measurements simultaneously, which negate the variability and the effect of a fluctuating customer load. So that's ratio testing. Do I see any questions or hear any questions for ratio testing thus far? Yes, Clint. You might be muted. Andy,
I'm sorry, I hit that by mistake.
Okay. Hello.
Thank you. Can you hear me?
Yes. Yes, I can hear you. Did you have a question?
Yeah. No, I hit that by mistake. I'm sorry.
Oh, okay. Okay. All right. Then we'll continue then. Switching gears to burden testing, a little more involved. Like I said earlier, burden testing, burden specification puts a operating range on the CT that the CT manufacturer guarantees the accuracy of that CT. If you have more burden on the secondary than the specified range, all bets are off. Now, granted, there will always be some burden on the secondary of that CT. The wires themselves, any corrosion on the test switch, any loose connections and interconnects. The meter itself applies some burden on that secondary, the coils. And so there is going to be some parasitic burden on that secondary loop, but it should be negligible. So we're going to use an example of a burden spec of 0.3% at burdens of 0.1, 0.2, and 0.5. This is a typical specification on some CTs, and this information, like I said earlier, will be located on the faceplate. And basically what this specification is stating is that the CT manufacturer will guarantee no more than a 0.3% plus or minus 0.3% accuracy or change in the secondary current from the initial reading when up to 0.5 ohms of burden is applied. If you go over that 0.5, like I said, all bets are off. So in a CT testing unit such as the 1047 on the left and the 1044 on the right, inside these units are a series of high accuracy resistors and inductors that allow the user to apply the standard burden test points of 0.1, 0.2, 0.5, 1, 2, 4, and 8 ohms. So in a burden test, using the ductbill and the ductbill cable and the test switch, you put the CT test unit in series with the secondary loop of the CT. The test unit will then will do a current measurement with no additional burden applied to the secondary loop to get the initial reading. And in this graph shown here, I like to graph this out. In this graph here, you see an initial current reading with zero burden, additional burden applied of 5 amps. Now, at this point, I do want to state that yes, like I said before, there is some burden on the secondary loop, like we know. But for the nature of the test, we incorrectly assume that the initial burden is 0. And I'll get back to that point a little later. But for nature of the test, you initially incorrectly assume, and you know it's incorrect, that the initial burden is 0. So you take, so the CT test unit will take the initial current reading of the secondary loop with no additional burden applied. Then it'll apply the 0.1 ohm test point and take a secondary current measurement. Once again, plotted here. And then throughout that range, 0.1, 0.2, 0.5, 1, 2, 4, and 8, the test unit applies those test points, taking additional current readings, and you will get a graph that looks something like this. So any questions at this point? Okay, I'll continue. But in this example, because the specification shown at the top of the page, this particular CT in this example is only guaranteed to a secondary burden of 0.5. So that's the critical test point shown at the arrow. And as you can see in this example, with 0.5 ohms of burden applied to the secondary, the change is less than 0.3% of the initial. So in this example, we have a good CT. So rewinding a bit to my statement earlier that we initially incorrectly assume that the initial burden on the secondary is 0. Well, seeing this graph here, if you were to see a very steep slope drop off right after the 0.5 test point, that would be an indicator that your initial burden on the secondary before you applied any additional was close to that 0.5 and higher than normal, and then that would be a telltale sign that you have an issue with that secondary loop. Corrosion, loose connections, wrong gauge wires, etc. So that's burden testing. Any questions? Okay. So now I'm going to shift gears to admittance testing. So what is admittance testing? Admittance testing measures the overall health of the secondary of the CT. The unit, admittance unit that we use is millisiemens, which is basically the inverse of impedance, the opposition to current. By doing an admittance testing, like I said, it measures the overall health of the secondary loop of the CT. How the units do it is they inject a high frequency sine wave signal into the secondary of the CT. You know the voltage that the signal was injected with. The current is measured. From those two parameters, you can calculate the impedance and the admittance. Now, admittance has a very big benefit in field testing. but then it also has some cons to it as well. The big benefit and the primary reason you would use admittance testing in the field is that it is the only no-load CT test method. For burden testing and ratio testing, by a rule of thumb, you have to have at least 10% or 500 milliamps of secondary current to have a legitimate test results with those two styles of testing. With admittance testing, you can test a CT with no load at all. So if you have oil wells or irrigation systems that might be not working at the time that you need to execute the test, those applications are great examples where admittance comes in really important. However, the admittance test results are not immediately intuitive. You will get a value back in millisiemens of, say, 12.5 millisiemens or 25 millisiemens. It's not as black and white, go, no go, as the burden and ratio test results. So what do all these millisiemens values mean? Well, we recommend, if you're going to use admittance testing, that you use a three-phase process. Ultimately and optimally, we recommend that you test each CT individually at the time of installation. And I know sometimes that's, for older installations, that's not applicable, not feasible. But if you can test the CTs at the time of installation, brand new, that's optimum. And then say for a 9S installation, you test each CT individually. And for instance, if you get results of 12.2, 12.5, and then on the C phase, 18 millisiemens, that's an indicator that that CT or that secondary loop of phase C has an issue with it. If those CTs are the same manufacturer, same model number, and they're a matched set. Then we recommend that you test the CTs over time and look for any changes of the resulting values. If you see one of the CTs in a match set slowly drifting over time, that could be an indicator that something has gone wrong with that phase. So any questions on admittance testing? Okay. So now I want to talk a little bit about interpreting the test results. So you go to a site, hook up the unit, run the test, the burden, the ratio, the admittance, and initially you get erroneous results, bad numbers. Something doesn't look right. I highly recommend that you never point your finger at the CT first. The CT should be the last thing that you consider bad in the secondary loop. CT is just a coil of wire. There's not much to go wrong with it. So if you get bad results from a burden ratio or admittance test out in the field, there could be a number of other things other than the CT that's possibly incorrect, bad, defective, unlike testing in a lab or a shop. Like I said earlier, there's different variables. So first, I would check the interconnects, make sure everything's tight in the secondary loop. Check your length of secondary cable. The wire gauge, make sure they are of your specifications of your utility. Look for corrosion on the test switch. Make sure that the meter is seated properly. All these could be issues in that secondary loop causing the bad test result. The first thing I would do is hit it with a demag function. The CT could be magnetized, and the CT can get magnetized for a number of reasons: harmonics on the line, lightning strike, temporary open secondary. It is my anecdotal experience doing CT testing for a little over a decade here with a number of different units in the field. I would say that approximately 60 to 70% of the time that I initially find or get erroneous results, bad numbers, 60, 70% of the time, those are cleared up with executing a demag on the service. After that, I would look for all those other issues, the wiring, the interconnects, the corrosion. Then after that, only when you have exhausted all those other potential failure modes, then I would look at the CT as a possible culprit. Okay, any questions on interpreting the results? All right, questions, comments? Andy, are you seeing anything on the chat? I can't see that at this point.
Yep, I had a few questions come in.
Okay.
One of the questions was, has anyone actually found a bad or out of accuracy CT?
I personally have not when I've been out doing demos and training. Anybody else on the call from the utilities actually found a bad CT?
Only a couple.
Only a couple? How long have you been doing CT testing in the field?
12 years.
Okay, that lines up with my point earlier that, yeah, you're very rarely going to find a bad CT. However, by doing CT testing in the field, you will find all these other issues, the bad wiring, corrosion, etc., which all lead to less revenue for your utility. And because of the nature of the application of CTs, you only use them for your high bill customers. It only takes finding one or two bad installations, not necessarily a bad CT, but something wrong with an installation, and there's your return on investment for the equipment and doing the CT testing.
It's usually found as incorrect multipliers. That's far more common.
Yes, yep, I see that. I see that often as well.
I don't know if you can you see the chat there, Rob?
Yeah, I saw one pop up from Kyle. Kyle, you there? Okay, I guess he doesn't have audio. He was saying that they find signs of tampering when they do testing, and yes, you're absolutely right. You will find instances of that as well.
And we also had a question on the chat from Kristen. Can DMAG be done at a customer site that has load?
Yes. 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 Doing the DMAG does not affect the customer load at all. So yeah, no worries there. I've done it many a times.
Okay, and someone who could not attend today's session actually emailed me ahead of time, which you guys can certainly do. I know we send out the TESCO rewinds, and sometimes you guys watch that after the fact. But if you see a session, you have some questions you want answered, you can certainly send them in to us ahead of time. And this question is for those of you that test CTs in the field, what type of failures or issues do you typically find?
I've listed a few. Anybody else have any other failure modes that they've ran into? Okay, Andy, we might have exhausted most of them.
Okay,
already.
yeah, it looks like Kyle replied, my failures usually find bad wiring, loose connections, etc.
Yep. Yes.
Pretty typical. Okay, that's all that I've been monitoring on this end. Does anyone have any other questions? Rob, if you could just flip to the next slide, that'll show next week's presentation. Thank you.
Yep.
So thank you once again, guys, for joining us for TESCO Tuesday. Next week, we have asset and inventory management coming up. Paul Fratellone, who's in charge of our TESCO software division, will be giving that presentation and talking about lessons learned in AMI deployment and using our meter manager software for asset and inventory management. And the following week, we have harmonics. And going into December, I can't believe it's going to be December already. We are skipping the week of Thanksgiving just so everybody can kind of take a break and relax that week. Then we're going to go into complete site testing that first week of December. We're going to do electric vehicle trends and calibration of commercial chargers. I know that's really big coming up next year. There's some regulations going in with that, so that'll be a huge one. And then we'll finish out the end of the year with streetlights and 5G metering and testing. We have a lot of exciting things coming up for that. So you guys don't want to miss that. If you're not signed up, you can always email us. You can always go to our website and sign up through there. You can just search TESCO Tuesday in the search bar. And again, be on the lookout for any of our TESCO Tuesday rewinds. If you missed it, you can also find them on our website under presentations. We'll have the video up probably tomorrow, and we'll have the presentation up shortly after we finish up here. So thank you guys once again. I hope you guys all have a great rest of the week. And hopefully we'll see you next Tuesday.
Good job, everybody.
All right.
Thank you.
Thank you, everyone.
Thank you, guys.